Hi Nico, it's Mark here. If you want to start, I'll admit guys into the lobby for you.
Okay, perfect. Yeah, I think we waited long enough, so we can rather start. It's Friday. Okay, let me just share my screen quickly, you guys. Okay, Mark, you're still going to hit the record on your side.
Yeah, I've hit record. You can start.
Okay, perfect. Okay, good afternoon all. Thank you for obviously attending this little training session from us. It'll probably just be taking a bit more than an hour. If there's any questions, stop us, or maybe just put it in the towards a mail, or maybe send it, put it down, and Mark can maybe answer it, or we can answer it later or discuss it. Doesn't matter. So my name is Nico from Cape Town Consulting Sales. As you probably want to know, aware of, we've got Consulting Sales Durban branch, Joburg branch, and in Cape Town. So if the need arises, you can't get hold of a certain area, obviously you can find different oaks, and we can assist where we can. Can I just ask you all to please mute, and obviously your camera is off as well. Sometimes it does play around the broadband, and sometimes it's stop and starting the whole training session. Okay, so today, this afternoon, we're going to run through a replacement VRV system. So what's it about? It's a new technology, or not new, it's an old technology that Daikin actually brought forward to replacing old R22 installations. It could be, as I said, our installation, or even if a need arises, we can look into different brands, because most of the pipe sizes are the same, and we can always look into the option of his to replace those systems as well. So all the topics we're going to run through as well this afternoon quickly. Introduction, the ban of R22, obviously mostly Europe. Daikin is in Europe. We're falling under Daikin Europe, although it's from Japan as well, the owners. So we actually applied especially strict rules on F-gas regulations from the overseas side. So that's our main drive. It's coming from our factory, and mostly it's Europe based. So we're going to touch quickly on the ban of R22, obviously F-gas regulation. Then we're touching the R20 replacement Daikin solutions. We've got two solutions at the moment, heat pump and the heat recovery. We'll get to it now. The unique flexibility of VRVQ, our replacement range. Customer needs, Daikin answers to obviously questions from the customer or the client. Approach to installers, because remember installers are still our go-to-get guys. They're in the industry, they know the buildings and know their clients and obviously the equipment installed. Then we're going to touch on a couple of VRV reference sites, mostly overseas, although we've done one or two in South Africa, and it's quite successful. And then just a conclusion. So first, we're going to touch on, as I said, the ban of R22. Everybody knows from 2014, from December, it was actually, but us as actually part of the SQCC, our safe handling, is from 2015 onwards. There was a ban put in place on the R22. Mostly refrigerant from there, new R22 equipment was supposed not to be manufactured anymore, although recycled or virgin type R22 can still be used for maintenance. Overseas, even on the repairs, if something breaks down and it's R22 based, the system must be replaced. So unfortunately, South Africa, we're slightly bit less strict on those demands and F-gas regulations. So by us, it's slightly a bit more easier, and obviously to get the refrigerant. So reclaimed refrigerant, as I said, is also a big drive in Europe, although we, even in the R410, is getting tight at the moment, and Daikin is also a leader again in refrigeration recycling. So the current regulations strengthen existing measurements, introduce a number of far-reaching changes, and the far-reaching change at the moment is 2050. So by 2050, although F-gas is put in place, and that's mostly to our old chlorine type of refrigerants, R12s, R22s, that's totally been banned. So 2050 is our target point now. after 2050, as everybody knows and they're all talking about in the industry, is the GWP, is global warming potential. But that's not our target today. So today we're just covering, as I said, technology that's replacing the old R22 that's been phased out already in the market. As I said, R410 is getting a bit more strict overseas to getting it. It's quite expensive, but R410 is still there to stay. You will see our VRV range is still as R410. Although we've got a big drive, we're actually trying to get even our VRV. We already launched mini VRVs, also on R32 that you know, our split range and sky range is already on R32. So there's quite a big drive on R32 for that as well. Remember, one of the pros from Daikin is actually we're the second biggest manufacturing of refrigerant in the world. So that's why we're one of the leaders in the refrigerant. That's why we've got first actually R32 in South Africa. So there's always a drive behind this new type of refrigerants, more working close to the market and even now the global warming potential to get the unique and the best solution going forward. So as I said, phase down, if it's not going to happen, there will be more emphasis on natural refrigerants as well. So that's a big drive at the moment to try to get this within the legislation. So Africa is also signed part of the what they call the Kigali Protocol, and that's part of the F-gas. So we have to also adhere to the same that's been put in place. So why focus now? The biggest focus, why we're saying now, there's a lot of still R22 systems that's still in the market and that's actually still running to that. So the problem now arises because Europe is phasing out, and it's almost like rather be proactive. So if you got a scenario now, for example, in a compressor failure, I just want to get my little pointer. So get to the first point. So you got a compressor repair at the moment. The problem is now you can actually give your client a quote to repair a compressor. So that's fine, all hunky-dory. It's a couple of $1,000 bucks. But the problem is now, if you replace the inverter board, because remember the inverter board is the driving mechanism of the compressor. So we always recommend to change both. It's like changing a direct line compressor. You've got a contactor driving that compressor. So always from our side, we recommend replace both. But the problem is now, maybe now you can do an exercise, get an oak system up and running, get the spare parts, replace it. But the problem is now, maybe you run into a lightning struck or ESCOM problem as well. That's currently happening. And you damage the PC board. Problem is now, a guy actually spent maybe 50 grand to repair his system. But now that PC board could have been a last on your shelf. And now that product has been obsolete. Your client is going to not really be happy. So that's why at the moment, I always recommend to you guys, if you do a repair cost in a quote, in an option, just do option A and B. Look into the training we're busy discussing, or looking at a total replacement option. But just give them all the solutions, just to cover yourself as well. But as I said, availability of space is becoming an issue. Remember, Daikin's got an agreement in place. We're trying to keep, or we guaranteed we'll have, after stop of manufacturing, we'll still carry 10 years of PC boards and components for that product. So that's an agreement we had in the industry and a norm towards our client. And you'll see even the R22 systems that we're trying to busy replacing and phasing out, there's 20 plus years old, and we still got spare parts for that. So I'm not saying that you won't get spare parts, but I'm just saying in the future, just look into plan B, as I said, replacing those units. So shortage supply as a refrigerant replacement, although R22 will be for, I think they asked for a while. But again, as I get more focus to the spare parts and breakdowns in the near future. Energy efficient building. Remember, a lot of people is now looking into drive of energy efficient. Is now the time as well, because the new technology replacing this has got all our new technology and all our functions built onto it. But we'll get to one or two little functions there that's available from a VRV4 onwards, even in a VRV3. So as I said, R22, right, rather be proactive, replace before negative impact, obviously in the comfort level in the building. So alternatives, three options. So either we wait and see, rather heat flames, kill fires afterwards, drop in refrigerant, as I said, it is available in the market for R22s, or upgrade existing systems. So that's the questions or three scenarios we got currently. Wait and see, obviously risk of system failure, especially if you've got a building in a call center, you've got a lot of people. Remember, tenants normally got a lease agreement, aircon must be running or they're not getting paid. So sometimes that could be becoming almost like a legal story. If your aircon is shut down and then suddenly we have got spare parts and then you have to get in and try to get people out of the building. So cost sometimes doesn't make sense to wait and see to get a breakdown scenario. Then again, spare parts availability while it's running, rather get proactive, get a solution in place, do it especially in certain shutdown periods, like we had COVID, or even winter times. At least you can actually get into the building to do replacement or repairs or new installation. And then obviously at some point you'll have to change the system. Remember, VRV system, it's comfort cooling system, supposed to be. A lot of people are threatening if the aircon goes off, you want to go home. Doesn't work that as comfort cooling, you won't die if it's shut down. But a lot of people, as I said, is always taking it quite critical if the aircon is not working. Life expectancy, 13 to about 18 years on VRV equipment. Remember, it's not the equipment itself, although spare parts can become an issue if legislation forces you to change it, like refrigerants, nobody foreseen it. But the problem is everything inside a building or inside a mechanical wear and tear has got a life expectancy. So life expectancy of VRV equipment as well is plus minus 40 to 45,000 running hours on bearings. So just remember that's why there is a life expectancy. It's not going to run forever. It's like any mechanical car or whatever, sometimes the bearing have to be replaced. So that's why rather it must be changed or will be changed or to be replaced in the future. Drop in refrigerants, as I said, there is a couple of refrigerants in the markets. Problem is most of them is blends, like R22 is a mono refrigerant, so it's quite nice. Got a leak, you can top it up. The new 4-range refrigerants, you can see it's all blends. So it's difficult. So even if you replace it, if you've got a leak afterwards, the cost to maintain it is going to be quite hectic. So high degradation system components, increased chance of system failure. Remember, you just add something, you're not fixing it. So you make it run for more, but the wear and tear is still happening or still in the system. So drop-in refrigerant, not, I think, the way to go. Option upgrade, definitely a discussion point. As I said, be proactive rather than run after the fact that it failed. So again, you can plan it, benefit of lower running costs. So we'll get to the efficiency now, so some little slides there. Reuse existing pipework, that's part of our replacement technology. So meaning you, especially old heritage buildings, you can't chop and change in roofs or even in the walls. So you've got that flexibility of replacing without touching the pipework. But there will be obviously checks that you have to perform, but we'll get to it now. And then obviously certain indoor units we can use. Reuse, unfortunately, cassettes is out of the range. Due to the technology on a cassette, swing flap motors all change to DC. Unfortunately, if you've got a cassette unit, you have to replace the complete unit. But we'll discuss it a bit later. Replacement system available, split air VRV systems, same as we've got that little chart, piping chart, and normally to that chart we can actually see what we can match to make it work to keep your existing piping. That's why I'm saying always go back to the consultant sales or your dealer sales guys. We can actually see what is installed and see that pipe work can be matched to get you a solution just to replace the system. And then obviously Daikin can also replace other manufacturers. So most of the technology or 410, remember, the refrigerant itself and oil and stuff can only handle, or a compressor, for example, 10 horsepower can only display so much, the refrigerant. So most of your piping sizes is all within range. So we can always see if you've got a system, we can obviously we have to take a measurements of a piping, but we can actually see from our side if we can match it by our capacity. And we, as I said, we've got a VRV Express tools. we can plot it in the Express tool, run it, do a piping schematic, and we can actually see where we can match piping. So that's also an option. Again, aging of equipment. Remember 10 plus years, 13 normal years, 13 to 15 to 18, that's your VRV life expectancy. So obviously you've got your first 10 years that everything is hunky-dory, is running like it's smooth because your wear and tear is quite limited. But after that, all of you guys know the guys is cutting back. So they're cutting back first of all, and everything is getting older. Previously, the whole layout of the floor was, for example, 100 kilowatt. Suddenly, the leakage in the building for more computers, they're running 150 kilowatts, so meaning you force your equipment to run longer, not cycling on or off as it's supposed to be. So all that efficiency has gone down the drain. So previously, when your cycle was designed for your load, suddenly your efficiency is going down the drain because first of all, wear and tear inside the mechanical parts and the misuse of the system. So that increases your maintenance costs and obviously your electricity bill. So that's one of your main causes for old system is becoming much more inefficient is obviously your wear and tear and how they handle the equipment. There's a pie chart of exactly a system. You'll see at the end of the line, efficiency is the most important of any system. That's why VRV and Daikin's VRV especially, we're always hammering on efficiency. Because if you go to the data packs and data books, you'll see Daikin, if you balance it out between other suppliers, efficiency is one of the best, if not the best. So efficiency, if you're looking at the life cost cycle of a VRV system, you will see the energy used of that system is 80% of that running time. So more efficient your system is, even if you've got a little price tag difference in the beginning, your payback, for example, a year after your installation, your payback will be paid, your difference between the cost will be paid back by electricity saving, and then the rest of your 15 plus years you save. So that's why efficiency is quite crucial in a VRV system. So this is so exactly if you, for example, in a 10-year period, we change it. So 10 years, we replace the system to a new system. If we go just the upper chart in the previous slide that we're going upwards in energy in maintenance, just this saving cost could be maybe for the next 3 years, actually just an energy saving, maintenance saving, can actually do a payback that actually in 3 years time, you actually pay back the total installation of the equipment, especially if you can keep the piping. And that's the whole exercise behind this training session we're running through as well, obviously to keep and maintain piping. So 2 solutions we've got. Let's touch quickly on the 2. Currently we've got heat pump system. Heat pump system is based on our VRV4 technology. I think most of you guys are familiar with our VRV equipment. So you'll see the latest models of VRV4, although we are on a VRV4 Plus range as well. But VRV4 is the most common and lately range we've got. And that's in the heat pump range. So to upgrade from R2214 system as cost effective as possible. So as if you can use reused piping. As I said, this is the technology behind this drive, keeping piping. And this is applicable, as I said, in Sky is also. So we've got a chart that we can double it and see what we can actually do to match. And then obviously to replace it, there's a sequence to follow. It's not just plug and play. So details through it as well, pipe specifications. That's why you have to go to site and see what is actually installed. So from there, lengths, pipe sizes. Remember, there's a difference in the pressure between 410 and R22. But luckily, the old R22 installation pipe work is much thicker, so the quality is there to handle the pressure actually. So we have to still double check diameters and then length and just see if that's within our parameters to actually replace the system. It's not doesn't make sense to replace it with new technology, quite expensive technology, and suddenly it runs a year and it dies, and then the client, everybody's up in arms. So if you want to do this exercise, most important exercise, if you want to replace it, get the history of that site. Remember, history is most important, especially in compressor breakdowns. If you've got a site, for example, that site was up and running 3 years, and there's issues and compressor failures and stuff, and suddenly the clients ask you, come in, oh, we got a replacement option. You maybe Google the internet, find a Daikin got a solution. He's looking into the solution. Please be careful. This is a solution, replacement, and keep piping. Remember, the heart of a VRV system is the insulation. Mostly piping because you've got multiple indoor units, got a system outside. The system is in the outer unit is built in to perform a certain oil management. Oil management, velocity, running up and down the system, open expansive valve, get your oil back. So your oil is your heart of any mechanical equipment. So if you've got a lot of compressor failures, mechanical failures inside a system, there's a reason. It shouldn't happen. As said, pro thinking, the system's running 10, 15 years old. There's R22 equipment, the system's not problematic. You go to proactive to the client, say, right, this is a replacement option we've got for especially PC boards becoming obsolete. R22 is being phased out. That's a factors you have to take in consideration to go to this technology. Just to heat another condenser to the system that's problematic, there's a reason why a system is problematic. And 90% of that system is problematic. It's either or misuse, not maintaining, or there's an issue with the pipe work. So as I said, don't plug and play this equipment if there's issues in pipe work and there's constant compressor failures to the system. Contamination of oil, a big cause. A lot of people, if you don't do a replacement, something happened, maybe it's coming worn, mechanical, you can hear it becoming noisy, mechanical damage to it as well. Remember, contamination of oil, there will be fine little metal grindings, so you have to do the correct procedure to replace it, like filter dryers. So you have to add something additional to try to limit it. Although the new replacement technology's got some features and functions to try to override this, the ownership is still by you to actually clean the system. Remember, our system can do some cleaning. There's some sort of cleaning they actually do by flushing, but it's a Friesen norm, of refrigeration and industry norm. If you replace a system and you reuse piping, flushed piping, you have to try to clean it as far as possible. And that's not a Daikin, that's a whole industry. Refrigeration, air conditioning industry is cleaning pipe, because remember, it's all different refrigerants, it's all different oils, and obviously your debris inside piping can cause future damage. So just to safeguard yourself. And then flare connections must be redone. Obviously, if you got a cassette, you replace the cassette, your flare obviously all the years running up and down from your obviously tightening it, you over flare it, all that flares is hard, so you have to obviously cut it off or reflare it to get your flares up and running again. That's just part of your installation. And obviously, certain units, but we discussed certain units you can use. So if you've got maybe the application, all of them is ducted units, then we just have to go and see if that ducted unit, we had maybe that same model available in the 410 model, because then we can replace the PC boards. And if it's all 410, it will work. Why I'm saying difficult, especially in cassettes, cassettes are technology total change. So if you've got a site, for example, you've got 5 ducted units, and we've got a PC board for the ducted units, for example, to get it as a grade, the software to be a 410, because that's what the other unit is looking at, the software. The one cassette must be changed. So if we change the one, and there is a setting on certain models, for example, if you're going to the K, the latest ducted units, but the K series, those units is R22. There's a setting on the other unit that we can actually set up so the R22 units will work. But as soon as we replace one indoor unit and make it a 410, then it's a problem. We can't combine R22 with 410 softwares, because the other unit will give you an error code, a UA error code. So that, the way to overcome it, if you've got the cassette for example, somewhere, there's a good chance that we have to replace all the indoor units to get to that same either or 410 or old R22 that's still compatible within the range. And Daikin offers 2 series in the VRV replacement, VRV4, we go up to 42 horsepower, and the heat recovery, we go up to 50 horsepower. We'll get to the heat recovery now. So, back to the basics, as I said, what's it all about? It's a heat pump system, two-pipe system, what we call heat pump. So meaning the whole exercise is we try to keep the piping. So inner units, as I said, we have to double check the compatibility. So we've got a list. So if you got a future project, send it to us. We can double check. If we're not 100% sure, we'll send it to the factory, see, all right, can we make it work? As I said, there are certain functions we can actually adjust. So we can change the software so the outer unit will see it as an R410 unit. So, but there is certain functions that we can adjust. So meaning indoor units to replace. If you can't keep it, piping we can all keep the same, and condenser we have to replace. So system automatic clean piping, as again, just remember that's limited, but although it's doing a certain cleaning performance. So just a broader picture of the whole installation. So meaning reuse bronze pipe, because we're still using ref nets. Even the first installation we done was ref net, so ref nets will still be applicable. So we can reuse. Freeze-run piping you can reuse. Indoor unit in certain cases. Indoor outer unit piping. Ref nets between the new models. You will see the old R22 systems had T-pieces in between. T-pieces was installed because the compressor technology inside the older units was what we call a low pressure sump. So the oil balancing between the compressors. Unfortunately, new type compressors is all high discharge sump compressors. So we've got ref nets between the modules. So the ref nets must be installed. So that's only pipe work that's been installed outside. And obviously new condensers. Piping is the same, obviously flares, or cut it off, put a little stop, new soft drawn and reflare it. Drain pipe obviously can be used, the remote controls can be reused. This the new models, but we'll get quickly back to the later one. We'll see a RXYQ 140, we had the 140, 180. Those is actually the sizes that's replacing the mini range. But a problem that we've got, and I'll show you now at the end of this presentation quickly what we can do with solutions we can check into is, unfortunately, these little smaller ones, there's only 3-phase. So at the moment, we haven't got a replacement for our mini range. For our 4, 5, 6 mini single phase condensers, we don't have a replacement technology. But again, we'll check into it as well. Then new sizes, we got an 18 and a 20 horsepower, also increase the capacity. Increase capacity, remember biggest difference between R22 piping, 410 piping. For example, we had a 3/8 liquid line on a 410, it will most likely still be a 3/8. For example, on a 6 horsepower, your suction will be a 3/4 and a 410 will be a 5/8. So you always have one size bigger. So the plus point on this as well, if you've got a system and I've got a 10 horsepower system, for example, I want to replace it, there's a good chance that you can actually upsize the condenser and use the same piping, because obviously the pipe sizes changes. So new features, as I said, part of your paybacks is new technology on the condenser unit. That's making it much more efficient. So energy saving is equal to your payback on the installation cost when it actually pay your total installation back to the client. So new features, VRT function, we'll get to it now as well. There's a technology, there's a patent from Daikin, it's uniqueness to Daikin. And this is why we're getting some good efficiency out of our systems. All inverter compressors from VRV3, we had always inverter compressor. The whole range was always inverter compressor first, starting up first, and then we had standard compressing making up the capacity of the modules. But the latest one is all inverters, is much more flexible and much more easier to smooth control. Connection to freezer units, so a VKM and air handling units, we can actually also connect it if you had a system, a site somewhere, and the piping allows it. You can actually, maybe where it previously was a ducted unit, we can actually add the small little air handling to it as well, if we can match the piping. Because now the new technology in the outer unit is compatible to the indoor technology. Start up by the configurators, that's a service tool. 7 segment LED display, so fault finding. You've got a little display outside with 3 error codes, so it's much easier for fault finding. Previous one is small 1 to 7 orange LEDs, and via LED and push button you can actually see, but it's quite a bit more complex to get into it as well. Continuation of existing features from VRV3 onwards, we had the auto charge. So auto charge is a function that you can perform to get the freezer 99% correct according to factory conditions. In an automatic test run can be formed. And then the leak test function can actually done on the condenser itself when a certain test run sequence was being followed, or you can actually do it remotely if you've got an ITM connected to the system. The high static fan, that's still applicable. We can go to 78, meaning you can actually have a cal or some ducting connected if you've got a plant room area that you want to fit the condensers. So that can still applicable. And a low noise operation is also still available in the machines. From VRV3 onwards, it was actually equipped. So VRT, variable freezing temperature, this, as I said, is a new technology, unique to Daikin, patented by Daikin. So what it does is actually using the ambient conditions. So remember, if you've got a fixed saturated target condition, like a previous VRV technology you had a 6 degree. Most of the guys, if you go to any coil designer, he will tell you the saturated temperature in a coil design will be 5 or 6, because that is where your saturated point on a evaporator will be. Our VRVs was always 6, and then from VRV3 onwards, we had adjusted, we can go up to 11. So meaning we can actually increase your evaporator temperature. So your off-coil temperature will be getting slightly higher, and your efficiency is getting higher. So that was part of that, what we call also like comfort conditions inside to overcome cold draft, especially if you've got low ceilings, and certain guys said you've got cold drafts on them as well, we can actually increase it. But that was fixed settings. The new technology in VRV4 that we've got to our system is what VRT is, variable refrigerant temperature. So what that system does, we're looking actually at ambient conditions also, and we map the indoor units, target return temperatures according to the set point. So what it does, in the relationship to the outer unit, it doesn't always, if your outer unit conditions is, for example, 25, it's not exactly the same as your peak on 35, for example. So why must your system still set the target saturated at 6 degrees? So that's what it's actually seeing in comparison. It actually rises your indoor unit saturated target temperature because your ambient is low. So meaning your thermal load in your structure in your building probably won't be that hot anyhow. So that time constraint is, or not time constraint, they actually done an exercise in the factory, meaning balancing out what is that time in relation to energy usage. And that is the energy usage is much better to raise a VRT, meaning via VRT, raise the temperature, saturated temperature. So this is a function that we got unique to Daikin, and this is why our efficiency is so great on our VRV systems. And this is a new technology, and even in your replacement VRV technology, we've got the same applicable to those condensers. But again, there's another additional feature, so because obviously all countries is not the same, sometimes by us, and sometimes maybe on your design conditions, we can have maybe a bit more load inside. So meaning that reaction time from outer unit ambient to indoor unit saturated temperature, maybe that time is a bit too long for your indoor conditions. At least on the outer units, we still got powerful quick mode settings. So meaning we can adjust that setting, for example, the balancing between ambient and indoor unit. If that relationship is too slow to act according to the indoor load, at least we can actually set it up as well to react quicker to your load conditions. So you've got also some flexibility to that. So VRT function, as is below, will always maintain that function if it's set on VRT. If it's not, and you want a constant condition running, then we can still play around in a saturated target setting to change it to a fixed setting according to your needs. But as I said, if it's set on VRT, it doesn't get your indoor conditions. It will actually slowly lower it to get your indoor conditions, because that's your system's always trying to achieve relationship between your return air and your set point. Commissioning, as I said, the configurator is just a plug-in tool from service guys that do some settings, especially if you've got a shopping center, hotel, or even a big project and you've got maybe 50 condensers outside, all your settings is the same. You have to do this powerful setting, your target saturating, some settings, high static, for example. You can always do it in your PC, on your laptop. You do a program according to your settings, and then you can actually plug and play and upload it to all the PC boards. So then I have to sit there and go through all the little parameters to get it set up. So it's just an easier setup tool. Just efficiency from all series, you will see Daikin was always running in alphabetical. So previous was a H or J, of a G in the H range, or VRV first series. Then we had the K, that was called a VRV2, and then we actually had the RXY SQM. So we always change the alphabetical, going up. So with previous VRV3, we were in P, so VRV4, we are now in T. But currently, one we've got is VRV the U range. So obviously, we will change somewhere. Q is always standing for 410, so that was R22, start 410, VRV3 onwards, VRV4, and a VRV4 plus is a Q. So efficiency, as I said, much bigger, the different two ranges from the K even to the H, but now we're running about 55% to 70% in certain modules, more efficient, the 410 lately to the old VRV2 series. So it's quite a huge upsize between the two previous efficiency-wise. Heat recovery. Heat recovery is still the VRV3 technology. You'll see VRV4 was always a top, flat top. VRV3 with the grids on top. So the casing is two different casings. VRV3 technology still applies to it, although the software has been changed to get you more, all the new efficiency is actually built into it as well. But technology, the hardware, compressors, the layout is still VRV3. Same applies. Piping can be kept in the units, depends on where it's lying, depends on our sheet, compatibility sheet. We have to double check and see if it's compatible or not. So piping can be kept. PS boxes must be changed. You'll see every time we do a change on condensers, meaning the hardware change, mostly our hardware in the PS boxes also change. So VRV R22 was still an M series box, meaning we had a 4-way valve in that box. So we changed to a VRV3, it was a P box. P meaning at the end was a P number, P7, P8. Those boxes was equipped with 5 expansor valves. So now, even now the 410, the latest VRV4, this box is equipped with 3 expansor valves. So every time the technology changes, we're always trying to change these technology to follow. Because remember, these boxes always had a pressure equalizing in them. Some had a little noise level to them as well. That's why we always recommend to have it in the passage, not in the same room. So we always try to perfect our technology to our hardware. So as I said, unfortunately, that can't stay, that they have to be changed as well. Then a VRV flushing sequence. Remember, in the beginning we said our VRV replacement technology had a flushing sequence in it as well. This VRV3 technology is slightly different. We had still a catcher built into it. It's almost like a container. So when it's doing the test run, normally a test run is trying to achieve certain conditions in the units and going to the other unit. So when the first test run is happening, it actually flushes through this catcher. And then after the test run, this catcher has been sealed by solenoid valves and it kept closed. So it's only the first test run that will be used. After that, it will never be used. But this is still in the heat recovery system. The heat pump system is slightly different. Heat pump had a catcher in it, but the heat pump now is doing a flushing sequence via the accumulator. So it's actually flushing the system back to the accumulator. What it does, we've got a level of separation between the different two oils, like a ester oil, our 410 oil, and a mineral oil. So one, obviously the density difference between the two, and there's about 2 big magnets that we fit inside the accumulator to actually get a hold of most of that wear and tear metal particles. That will stick to the magnets inside the accumulator. So that's all technology we try to implement to the system to see how we can get the system as clean as possible. But remember, still an industry norm, clean your piping, get it clean as possible. If you've got a site, if there's some little chance of you're not 100% happy with the system, go to the cartridge filter system, implement that, install it, rather be 100% safe before just replacing the equipment. You see different modules, RQ, EQ. E is always standing for heat recovery. You will see RXY, we always have the Y for heat pump, meaning Y is for year round. So it's heat pump system, heat recovery system is E. This is actually the first time, because maximum will go to 50 horsepower. Will be the first time that you will see, if you maybe it's got a project that's happening as well, that you have 4 modules on a VRV condenser system. Because normally our condensers will always be 3 modules maximum, but in this replacement to make up the capacity, we're running 4 of those same models to make up the 50 horsepower. Unique features, as I said, automatic cleaning of all piping. Again, at sequence, remember via the cartridge or via the accumulator, so some sort of cleaning. Ownership still on you. Automatic charging with new refrigerant. So when you're done, we normally do, as I said, we do a calculation. Part of our software, we can actually put all the measurements in. The software will tell us, right, that this is how much added refrigerant must be added to the system. So we can manually add it, or we can do an auto charge via this charging method. But there is certain conditions limited to auto charge. So just remember that as well. Changing old units with new ones, versatility, especially cassettes, 800 by 800 is still the same. So your sealing won't be a difference, but won't be need to cut or change any sealings. That will always still be the same. Possibility to change competitive product of competition. Remember, it still need a layout being measured, being signed off, and we can see how we can actually match it. And then obviously increase the capacity, because R22 piping was bigger than the 14 piping. Just a contamination sequence. Again, if the guy's doing like Daikin is starting or commissioning the systems, we'll run it through a sequence, especially like the old technology from the beginning. It was always doing a flush sequence before you can do a test run. So part of the auto would always go to the auto charge with that combination of flushing sequence automatic before you can actually just test run. So there's no way for you to bypass it. That was a safety built into the system. And then obviously no need to calculate volume of refrigerant, because sometimes you can't get to the piping, you can't measure it. So that's why you've got an auto charge function. And normally if you can't get to piping, you can't measure it, the auto charge must be done. That's the most accurate way to charge it. Or else Daikin service tools, they've got a service checker, they can actually run it, and that's also 99% accurate to get the charge correct. And then there's no need to clean piping inside. Just remember as well the industry norm. So the way it actually dealt with it, if you check the infill chart, what it does on the condenser side, we've got more compressing circuits, subcool circuits, decompress technology that actually lower the head pressure as well. From my opinion, what I've seen as well, it's not really that much, although there is slight difference between the two, but there's not really that much difference on running pressures between the two, because the system will still try to get the saturated temperature inside. Where this is playing a role, obviously your upper limit is running on heating, because then you change the system, and then obviously your discharge will be your old R20 piping, your heat rejection. Minimum fall sealing, so as I said, 800 by 800 is still applicable, so meaning your hole size, your sealing sizes won't be really affected if you go and change the cassette unit, so that still stay the same. What nice is, as I said before, you'll upgrade on the system. So previously you had a system, for example, 10 horsepower times 2, your 20 horsepower system, 2 horsepower systems inside. You'll see that system normally a 1/4.5 inch is a pipe size from a 20, 25, 32, 40 up to a 55.6 kilowatt nominal. That's still the same. If you go to 6.3, then it changed from a 1/4 to 3/8 to 5/8. So if it's still the same, you can actually, previously we had the 2 horsepower little unit there, we can actually upsize it. Due to the R22 pipe sizing that's bigger, we can actually add 2 16 horsepower now to compensate for a better or a more capacity that's installed now. So as I said, again, remember technology always changes. Sometimes exactly the same in a building. Previously, a building had 5 people sitting in it. Now suddenly it's a call center. Previously, there was an old desktop computer. Now it's some 5 guys sitting there. So your heat load is always different. So at least from there, you can double check and see, right, if you can actually increase capacity to it. Then again, what's nice about it, footprint size, because technology totally changes. So your condensers, the older condensers, it was much bigger. I'll get to that now. Okay, I'll discuss quickly now. So your condensers was much bigger. For example, our 10 horsepower, on an older 10 horsepower, it was even bigger than the 16 horsepower. So your footprint size, you probably can get that same condensers, although you're 160% oversized, we can actually still get a condenser in the same footprint. This is a chart what I told you about previously. That's the 2 smaller ones, the mini range. That's replacing your 5 and your 6 horsepower. But as I said, biggest problem there is 3-phase. And there's a lot of minis that we've got outside in the industry that we've got a issue. Again, as I said here, if you go, for example, 5 horsepower, smaller little system, 5 horsepower, liquid is always 3/8, R22 as well, and 410. So your standard size will be 5/8, but we've got a possibility to slightly increase it. But I'll show you quickly now in a little selection of time. So customer needs and Daikin answers to his needs. First of all, interruption. That's the biggest threat of all these guys say, but how are you gonna do it in certain areas, because I've still got my tenants, I've still got people in the building. So that's the biggest discussion or issue around worldwide when we've done an exercise, is the most pro was actually quick installation, because interruption for business was always the biggest issue. As said, this partial 5%, that's pipe sizes, running costs, cut, all this issue, but the biggest problem on them from the client side was insulation was issue. How are you going to do the insulation? So office owner will obviously ask you, just finish the ceiling, decorate, want to destroy it, it's expensive, so don't touch the ceilings. As I said, like I said, the units is all the same, so it shouldn't make a difference. So this is all the questions being asked to different tenants and owners and consultants. What is the risk about the replacement technology? But as I said, if you can keep the piping, because the units are still the same size, your threat of damaging, again, old ceilings or new ceilings that should be maybe, for example, repainted, decorative panels, everything will be exactly the same, so it's easy to fit, especially if you start doing it in phases. By planning phase installation, not the disruptivity, replace outer units now. Remember, that's your heart. So that's where your failing rate is outside. If we can change, or if we can use certain type of indoor units, we can replace it. And then obviously new, maybe the client want to revamp inside, then at least the heart is outside, that's running, and then we can change the cassette units. Even from there, upgrading to different controllers as well. It's not really going to cause breakdowns, although new controllers is much more technology based, as I said, Bluetooth type Madoka controllers as well. So these are all the benefits of installing it in phases. Obviously leaving the pipe book full about a third of the time, low impact on the end users, performing after hours. Most of the buildings, I'll show you now quickly 1 or 2, that's been done after hours. Retrofitting DX with another refrigerant can be initially cheaper, but old ignition may become later source of problem. As I said, remember spare issues, although R22 will be available, but discontinue of obsolete spare parts is a possibility in old R20 systems. And then obviously efficiency again will probably be after cost, and that's part of your what we call your payback on it. So just coming back to the old copper, that's what I'm saying. You still have to pressure test your copper piping to make sure that's fine. But the older copper, as I said, experts already believe bare copper functions well over 100 years. Certain copper very durable, being tested between 50 to 60 years, no problem as well. And as I said, the quality is much better than the older. The wall thickness was bigger than the minimum criteria currently. But still, again, must be measured. We double check it. And then we actually carry on to design and make a new solution for a replacement option. Pressure test, exactly the same as currently, commissioned by Daikin, exactly the same. So pressure test will be done, a vacuum to 500 less microns, 24 hours or hour standing. So those conditions is part of the all pre-commissioning checklist and part of the commissioning that will happen obviously before we get the system commissioned up and running. So nothing changed in those. This is still applicable in the replacement or the current installations. So if you can use the old piping, why not using standard VRV unit? As I said, there's different technology piping because the decompression on the system, especially if you've got all the piping inside, if you change the reverse cycle to heating inside, and it was maybe not the correct size or correct type of copper, you're going to have issues. So this is the reason why we've got a replacement system. And then obviously old oil, mineral oil, synthetic, also named ether oil, it's not clean completely. Oil will be thick, becoming a sludge, and that will obviously combine inside and causing jamming up your expansor valves and causing high acid and compressor failures and all that. So cleaning of equipment, sometimes I know that it's difficult to get all it clean, but as far as possible. And as I said, if you still got a chance, maybe rather put a filter cartridge system to this well to make 100% sure the system is clean. Pressure test, exactly the same, and then obviously the decompression and the technology that lower the pressure, especially on heating. Okay, we only change VRBQ auto units, keep the old units. As I said, certain units we can, but remember, all the latest ones is new technologies. You always can actually go for the latest technology because that's also part of efficiency. If you've got a building, we got 100 cassette units, you want to replace little phases, it's always advisable to maybe go for the option, maybe later change all the units as well, because remember, there's new technology. So new technology is self-cleaning panels, movement sensor. So that's all aspects that actually running your system much more efficient than the older system. So even DC fan motors, so your functions to it to replace it is much more than the older units. And especially if you've got a bigger site, bigger building with 100 units, all that efficiencies, all that usage actually just play a role in your total cost and your electrical usage. Again, technology add onto the system. So from a VRV, actually from a VRV2 onwards, technology we add of F1, F2, we can actually incorporate technology like a ITM, iTouch Manager, where we can actually supervise the usage of the system. We can control it. We do limits. We can actually shut down the systems. So meaning we can totally manage the control. If there's end users or different clients, whoever is misusing the system, at least you can monitor it and control it. So this is also always advisable to have this, especially if you've got a building with a lot of people inside and you haven't really got control to as well, because you can actually set limits and you can stop and start times as well. So that's all part of your energy saving tool to your end user. Then also add onto it as well your remote dialing to monitor it, or you can actually do your different PPD billing for your different tenants if you've got multiple tenants of the system. So just a sample of a previous one. Again, back to your footprint. So footprint from older units to the new ones, the footprint in a VRBQ, meaning the 4 is much less. So either or you can actually have more service space around the condensers, or you can actually leave it the same, but you can actually add more capacity to that plant room, for example. This is an example of a previous one. Previous one, we had little inverter compressor. We had the standard compressor making up the capacity. We had our 4-way valve changeover box, what we call a function box. This now is all included in one unit. So if you take that your footprint area, 2.2 squares, like not even 1 square, I said there's much more space friendly than the older ones. That's why I'm saying you can even if you take this, you can even double up this in the same footprint and double up the capacity. So approach the installers. Remember, most of your buildings, we as Daikin, we've got also turnaround and staff. Sometimes we don't have all the luxury of having all the info on site. So our installers are still our eyes in the industry, especially if they got maintenance contracts inside or outside there in the industry, because they will have the buildings and the knowledge of which buildings are still R22 buildings, which buildings has got history of running, which buildings is maybe a good project maybe to do a replacement. So as I said, our end users, our installers is always our heart in communication between us and to keep us knowledge up to scratch what's happening to our older industry, of the older technology running outside in the industry. So we always can actually do a joint venture. We can actually assist you guys with part of this, actually go to the client or give you proposals, and you can actually forward to the client to tell them the new technology, what we've got, obviously to replace it. We most likely prefer to install complete new installation. Obviously, we're not taking business away by leaving the pipe work. It's just a different solution. Sometimes owners will rather go that route than obviously keep it back till it runs to fail. And then massive cost and exercise disruption to change the whole system. So although, as I said, we're not trying to take away work or, like I said, money, income from our installers. So from installers, comments from their side, most owners only act when they're forced to. I said, unless we can always try to get proactive to it as well. Estimate that at least 50% of tel groups still have R22 installed. Even in Cape Town, by us, we know still a couple of buildings running R22, still operational. We pitch a cost between 20 to 25 difference between the full replacement cost and obviously the new to a replacement. But again, there's disruption. That's always playing a role. That's the biggest aspect to most of the end users, is their point of concern is disruption. And obviously sales people between obviously the maintenance guys or our dealers is obviously the key factor of spreading the knowledge of our replacement technology. And then the tightness test, unknown diameters, solved by a leak test and auto charts, obviously within a range, but we can actually do a pre-inspection, and then we can actually from there take it and compare our technology pipe sizes with our software to what is actually installed. We can actually come to a solution or outcome from there. References. Most of people say, I've never heard of product. We have successful cases. Yes, especially overseas. By us, it's not huge projects running. The only bigger one we've got in Cape Town is we've got what we call SRG building. That building was running 20 plus years, and we started 2 years back in phases, changing those units. And there's about 68 condensers, between 8 and 10 horsepower single systems that we replaced on that roof. And those units were running in that 20 years. I think we had a discussion the other day. I think we had about 2 or 3 compressor failures in that whole time in that building. So that was a perfect opportunity or project to use this replacement technology. And we finished off the, I think just before COVID, the last systems was there installed and up and running. The huge energy saving in that building as well. So R22 replace, excess of 32 energy saving, 35% energy saving. And then next factor, as I said, after 2030, global warming potential, GWP, that's also going to play a role. So even from an old R22, your CO2 emissions is definitely playing a role. So we can get to a bit more ozone-friendly refrigerant. Again, building Osaka, 1987. We started 85, I think 86. We started with VRV. So Osaka is our head office, so that's probably why it's one of the pilot buildings. More than 20 years from first installation. As I said, we had the same scenario by us, more than 20 years running before we start changing it. So as I said again, heart of installation is always the installation. Dry and keep tidy and within the specifications. Phases, floor by floor. This is actually a study what was done on the Osaka building, how they actually done it. So for less interruption. So what it does, short installation period, so that actually 8 days a floor. So this is actually the amount of people that work in that installation. One area, 2 days, Saturday and Sunday, so they went in after hours. open up, lift the piping, change the indoor units if it was applicable to change, and change the condenser were up and running. So interruption was actually to the minimum on this project. Space saving, again, if you check where the condensers, plant little rooms in the corners, so obviously more space saving by the new type condenser with a less footprint as well. So there's the energy saving. We take two models from 86 horsepower, 86 horsepower. If we had the older technology, VRV-G, meaning the first generation VRV is still there, we've got about a 32% saving on the same capacity. So I'm not going to run that. Just another little site, Italy, where we actually have construction. Change it. Just what is combined. The K was our VRV2 range. And obviously a new type solution for it as well. So the options is there. As I said, our biggest one we got now was our SRG building in Cape Town. We've done, there's a project also, Kierboom Chambers. There's also attorney offices in Cape Town. There was also about 10 systems, but there's also smaller systems that's been changed in phases. Every system had about 4 to 6 indoor units. All of them was mid-walls. We kept all the piping, and all the mid-walls has been replaced with new fancy look controllers. And because the A-type indoor unit is much more, obviously looks a bit better on the eye than the older ones. Than to change PC board. Oh yeah, and then we've got another one at Reach, Isuzu Reach. We changed a 40 or 38 horsepower system, and that system is now running about 6 years after installation, not today's issue. So we've got a couple of reference sites that's up and running by us as well. Just Italy, as is obviously the gang chart and time frames they actually worked on to replace it and repair it, or replace and get it up and running, commission systems. So from March 12th to August 12th. That was the previous project. So same, that's the one we talk about. So conclusion, R22 forces have been installed, new market, 100,000 VRV plus competitors, it's opportunity still. So there's still a huge market to replace this in the technology. So that's why we're trying to promote this as far as possible. If you got a projects on this as well, please let us know. Get us involved. We can actually always assist in the site visit, walking around, double check and see what's about, and see if we can actually make it work or make it a project for us as a reference site. I just quickly want to show you a, let me just get to this. I just want to show you quickly this VRV selection that I've got in a mini VRV. Mark, can you hear me?
Yes, I can hear you.
Is there any questions from you guys, or did somebody send any questions? I just want to open up my Express quickly. Just want to show the guys on a little selection. Is there any questions from anybody? Maybe while I'm quickly opening up this my selection tool, I just want to show you quickly a little selection on the 4 horsepower I've done. Okay, it doesn't look like it. Okay, just opening up my VRV selection. No questions from anybody? You're welcome to send us mails as well for more info, technical data on these machines, on condensers. We can gladly send it to you guys. Computers in Friday mode. Okay, let me just, I just want to quickly move my screen. Can you still see my last screen, Mark?
Yeah, your PowerPoint is still up.
Yeah. Okay, let me just, I just want to move this quickly. Okay, can you see this one?
Yeah, I can see your selection software now.
Okay. So this is actually, if you've done a little exercise, we've got little pen here as we're looking into obviously the replacement issue, but the problem is in a single phase replacement technology, we don't have a 4 and a 5 and a single phase horsepower. So we have to try to see how we can actually make it work. So if we go to piping, for example, remember all our VRVs, even a 410, what we got currently, those units is limited, obviously, main pipe lengths. So if you got a compact, our compact is limited to about, I think, total 80 meters. Our mini range, our mini top double fan is our mini range. Compact is a smaller compact that we've got. That is actually a single phase. Let me see if I can actually change to a compact. This is the one that we currently are going to bring out in a R32 quite soon in South Africa as well. It's already been launched overseas. So this is our compact range. So certain condensers is limited to certain pipe lengths in total. So if you're going for example, if we go to a 5 horsepower compact, it will give me a 3/8 and 5/8. If I go to a 4 horsepower, if you've got a site in a 4 horsepower, my piping is also 3/8 and 5/8. That is the 14 matching. So if I've got a previous system and I had R22, for example, in the 4 horsepower, I need 3/4 and 3/8. So if I go to my 6 horsepower, for example, just want to change it quickly to a. So if I change to a 6 horsepower, I'll get my matching size. So meaning if I've got a scenario somewhere and I've got indoor units that are at maybe a 4 kilowatt indoor unit, then I can actually change that maybe to a 5 kilowatt indoor unit, and I can reuse that piping. So there is means and ways to actually see if we slightly oversize the system or maybe increase the capacity, because you don't know obviously of the thermal condition inside the building, or maybe the capacity is what currently inside the building. So there is a chance to see if we can match the piping that's previously installed. So that's one of the ways to actually try to see what we can do. But if there's an issue, maybe an electrical power supply to the system, for example, and this is our mini range, we've got a 4 horsepower system, for example, but our pipe size doesn't match. Just remember, our 4 horsepower, we can actually go longer pipe lengths. So this is one of the luxuries of this mini range on pipe lengths. So we can actually get more, especially in higher apartments as well. So if we increase this length, for example, let's get that to 90 meters. So suddenly what it does is actually upsizing my piping. If you check it upsize my piping, it doesn't give me an error code. So meaning this is within a total capacity and total range of the system, and it does upsize to my 3/8 and my 3/4. So it's upsizing to my correct R22 piping. So my opinion, if the system is slightly smaller, I should be able still to use a 4 horsepower to that system, because the software upsize that piping, but still allows me to use that sizes. So that's what I just want to show you quickly. We can always play around and see how we can actually work around it, how we can actually manage it. Because as I said, if you've got an indoor pipe size and it's a different size, we can always see if maybe that area, maybe that previous lounge area, we can actually maybe just go one size up from a 50 to a 63. Physical size will plus minus be close to the same, depends on which units, for example, mid-walls. But then with this, we can actually match the piping to make it work. Does that make sense to all of you guys?
Yes, that's fine.
Okay, so Mark, that's my short and sweet little training session. So I'm not sure if there's any more questions or requests from the guys. They can always, as I said, send us mails to our local sales guys, myself, doesn't matter. And we can reply to what is needed from our side. Any questions before we log off? Okay, cool. Thank you, everybody. We actually sit in the training, use your Friday to actually sit and listen to me. As I said, going forward, hopefully we can do a couple of replacement projects for you guys. But any assistance, any info, please let us know. We'll assist where we can and try to see if we can make it work for you guys. Cool. Thank you.